Welcome to lesson 4 of our biomechanics unit. So this lesson is all about levers. Now we have previously looked at levers in our movement analysis unit before Christmas, but this is going to go into a little bit more detail. So we're going to cover lots of different things. We're going to cover all the different components of a lever system. We're going to look at the 3 different types of lever, and we're also going to look at mechanical advantage. So, introduction to levers. So we know that the joints in our body, they act to allow movement, but they also act as levers. So each of our joints in our body is a different lever. The joint itself is the fulcrum, the pivot, and this pivot point takes the strain. The force is provided by the muscles attached to the bone, so think of the muscles acting as a pulley system, and then the resistance comes from body weight or any implement used for sport, for example a bat or a racket or a dumbbell or things like that. So keywords, so this should be a bit of recap from when we last looked at levers. So we have the load, which is the weight or the resistance, or whatever you're holding or moving. We have the effort, which is the muscular force used to produce that movement. Then we have the fulcrum, which is your joint, and then the lever is the bone. So we have something known as a resistance or a load arm. You can call it a resistance arm or a load arm. Both are correct in terms of when you take your exam. So the resistance arm is the part of the lever between the fulcrum and the resistance. And the longer the resistance arm, the greater speed can be generated with that movement. This is why fast bowlers in cricket are tall with long limbs, because then using those long limbs, they can create more speed with their movement. And so you can see here the diagram. So you've got your fulcrum in the middle, you have your effort arm here, and then you have your resistance arm here. So this is a big rock. The human is trying to produce the effort to move the rock. Now because the resistance arm is quite short, then that means that the effort is that the resistance is going to be harder to move. So there's not much speed going to be produced with that movement there because the resistance arm is very small. Now the effort arm is the distance between the fulcrum and the effort, the muscle. And the longer the effort arm, the less effort is required to move a given distance. So for example in sport we use things such as rackets or bats to increase the length of the effort arm, which will then increase the force that an object such as a ball is struck with. The optimal length of an implement should be determined by the strength of the person handling it, which is why, for example, we have junior tennis rackets that are slightly shorter because the effort being produced by a child's arm is much less than the effort produced by an adult's arm. And here you can see the effort arm is much longer, and therefore it wouldn't take as much effort to move that rock. The rock would move with less speed because the resistance arm is small, but you would be able to move it with relatively less effort. So here we have our different types of levers. So this one here is a first class lever, and you can see fulcrum's in the middle. This is your resistance arm here, this is your effort arm. They are normally relatively equal. Now if we look at a second class lever here, fulcrum's on the end and the load is in the middle. Therefore the resistance arm is much shorter and the effort arm is much longer. That means that it has a bit of an advantage because it requires less effort to move that load. Now here, class 3 lever, you have your effort in the middle, so the effort arm is shorter, and you have your load on the end, so the resistance arm is longer. This means that it takes more effort to produce movement, but that load can be moved a greater distance and at a greater speed. Now levers have 2 functions. The first one is to apply force or strength to an object. So remember, the longer the lever distance from the force to the fulcrum, the greater the force generated. So using a wheel brace enables a motorist to undo the nuts on his or her car tyres much more easily. Or it has the function to move the resistance a greater distance or through a greater range of movement. So we're talking here third class levers. To apply force or strength we're talking second class levers. For this one we're talking third class levers. The closer the effort is to the fulcrum, the greater the distance moved. It might take more effort, but you get more range of movement. So if we asked you to hold a bicep curl in an isometric position, so isometric, remember, is not moving, it's stationary, where would be the hardest or the easiest phase of the curl to hold the position? I'd like you just to pause the video and have a little bit of a think about how you would answer that question. Okay, so the answer. So if we look at this position here, now the weight is relatively close to the fulcrum because we don't measure it along the lever, we measure it that way there. So the weight is relatively close to the fulcrum. Therefore, it requires less effort to hold it, okay? Because the resistance arm is shorter. However, if we extended our arm out, suddenly the weight or the load is much further from the fulcrum. So that arm there, the load arm, is much longer, and therefore it requires more effort to hold it, and therefore if you're holding that bicep curl at an extended position, it would be much more difficult than holding it in that position there. So if we just go back through the three different types of levers, so we have our first class levers or first order levers where our fulcrum or our pivot is in the middle. So fulcrum's in the middle, doesn't matter which way, but the effort and the weight are the either side. So again, doesn't matter which side, but remember our load arrow always goes downwards and our force or our effort arrow always goes upwards. First class levers are organised like a set of scales. The fulcrum's in the middle, effort and the resistance either side, and the best example from your body is the head. So you have the fulcrum in the middle where the spine joins the skull, and then you have your effort to one side using where the neck muscles move the skull, and then you have the weight. The most of the weight of the skull is distributed towards the front near your face, and therefore that is a prime example of a first class lever. Second class levers, we have the load or the weight in the middle. Okay, so the fulcrum's at one end, the effort's at the other end, and the load is in the middle. Remember it as ELF. Again, the load arrow going down and the effort arrow moving up. So when the resistance lies between the fulcrum and the effort, then it's a second class lever, and the best example in the body is the ankle joint. So if you raise up onto your toes, where the toes are in contact with the floor, this is the fulcrum, that's the pivot point. And the body weight, the load, is the body weight coming through your shin bone down through the middle of your foot. Now the effort for this movement comes from your calf muscle being attached to your calcaneus, which is your heel, through your Achilles tendon. Now the effort is that side of the weight. This makes it a second class lever, and so when you stand up onto your toes, you are using a second class lever. Now third class levers are the most common form of lever in the human body, and this occurs when the effort lies between the fulcrum and the resistance. So the effort's in the middle, and you can see here the fulcrum's the elbow joint, the effort is the bicep attached to the forearm here, and then you've got your weight, whatever you're carrying, or just the weight of your forearm is your load. Now in terms of applying force, it is a very inefficient lever, but it does allow greater speed and range of movement. So again here, the force arrow is going up and the load arrow is going down. Now the way to remember the three different lever systems is FLE 1, 2, 3. So first class lever, F for fulcrum is in the middle. Second class lever, the load is in the middle. And then third class lever, the effort is in the middle. Now using that knowledge, I would like you to try and identify what levers the following examples are and try to draw a diagram to demonstrate each one. So elbow joint with the triceps lowering a barbell, so we're looking at extension. The elbow joint with the biceps raising a dumbbell, so we're looking at flexion. And then the ankle joint, a calf raising the body onto the toes. I'd like you to indicate the effort, the load, the fulcrum, and the muscles and bones included in the movement. If you pause the video and then restart the video once you've completed the task. Okay, so the answers. So you have your first one, elbow joint with the triceps, the extension movement, is actually a first class lever. The fulcrum is in the middle, and the tricep muscle is to one end, and the effort, the load, which is the barbell, is to the other end. Now, the second example, the elbow joint with the biceps with the flexion, this is actually a third class lever. Your fulcrum, your elbow joint, is at the end. Your bicep attaches to your forearm in the middle, and that is your effort, and the dumbbell, which is the load, is on the other end. And the third example, the ankle joint in the calf, as discussed before, this is always a second class lever. So the toes create the fulcrum, the calf muscle is the effort, and the load in the middle is your body weight. So as discussed, we have two main functions of levers: to increase the resistance that a given effort can move, or to increase the speed at which the body moves. Now, a first class lever can increase both the effects of effort and the speed of a body. A second class lever tends only to increase the effect of the effort force, and the third class lever can be used to increase the speed of a body. Now, if we look at the human body, the majority of movements in the human body are governed by third class levers. So third class levers will increase the speed and the range of movement of the body. And a prime example of a third class lever is the knee joint, where you have the action of the hamstrings and the quadriceps, which cause flexion and extension of the lower leg. And if you think, you can create a lot of speed at that joint and a lot of range of movement. So if we compare the two of the different types of levers, so second class and third class levers. So second class levers, the pros are it moves a large load with a very little force. The effort arm is greater than the load arm, and because the effort is further away from the fulcrum than the load, it requires less effort to move a larger load. The cons of that are you can only move a small range of movement with poor speed. So if you think about you stepping up onto your toes, you can't move very far. It's a very small movement. Yes, you're moving a great weight, but it's a very small movement. Now, third class levers, the cons are that it takes a large effort to move a small load. The load is further away from the effort, and therefore it requires more effort to move it. The pros, however, is that it can move that load at a speed and at a wider range of movement. So when we talk about mechanical advantage, we're talking about the relative efficiency of the lever system, and it's expressed as a mechanical advantage, and it can be determined by the effort arm divided by the resistance arm. And obviously, the larger the result of that calculation, the better the mechanical advantage. So if you look at second class levers, where the effort arm is much greater than the load arm, that means it has a high mechanical advantage. A large load is much easier to move with relatively small effort. However, the interesting thing is that the human body is made the majority of the time it's made up from third class levers, which says that the human body has compromised in order to have a greater range of movement and more speed. It's compromised with having to require more effort to produce that movement. It's not gone for the mechanical advantage. Some joints, obviously the ankle joint has that mechanical advantage, but the majority have compromised and gone for speed over effort. So we're going to use the knowledge that you've just acquired to apply it to different exam questions. So the first three questions here, I would like you to take 7 minutes, so pause the video and take 7 minutes to answer. Okay, so the answers. So the first question, sketch a second class lever system in the box below and identify the effort arm and load arm. So the answer here, so you get 1 mark for having the fulcrum, the load and the effort in the correct order, and remember the load arrow has to go down and the effort arrow has to go up. So that would get you 1 mark. You get 2 marks for saying that the effort arm is from the fulcrum to the effort, and then you get 1 mark for saying that the load arm is from the load in the middle to the fulcrum, and that's how you'd get your 3 marks. Now question 2 is describe a sporting example of a second class lever system in the human body. Now the most obvious one is to use your ankle joint, but you have to apply it to a sporting example. So you could say standing on tiptoes to defend a shot in netball, or jumping from the ball of the foot for a rebound in a basketball, or a press up where the fulcrum is the toes and you're moving in that press up, you're pivoting on your toes to produce the press up. As long as you've used the ankle joint and applied it to a sporting example, then that will be accepted for the mark. Now, the third question, explain why a second class lever has a mechanical advantage for 2 marks. You get 1 mark for saying any of these following points. So the effort arm is longer than the load or resistance arm, or effort is further from the fulcrum than the load. The more effective or efficient at moving heavy loads, or it can move a large load with relatively small effort. Mechanical advantage is effort arm divided by load arm. The closer the load is to the fulcrum, the greater the advantage, or the greater the distance between load and effort, the greater the advantage. So there's lots of different ways of saying essentially the same thing, but you'll get 2 marks for saying 2 of those points. Okay, so one final exam question, 4 marks, 4 minutes, pause the video, off you go. Okay, so the answer. So using practical examples, explain how the elbow joint can act as a fulcrum for 2 different lever systems. Now we looked at this previously in the video, so you'll get 4 marks for these 4 points. So you'd say a first class lever for extension movements and give the example of a triceps extension or throwing an object or a tennis serve where you're straightening your arm. And then you need to explain that the first class lever has the fulcrum in the middle, and then you can provide an appropriate diagram. Or you don't have to provide an appropriate diagram, but you can if you want to. You'd get a mark for that. Now, a third class lever is for flexion movement, so a bicep curl, or up or downward phase, and then the second mark for that section would be gained through saying that the third class lever has the effort in the middle or providing an appropriate diagram. Okay, so that comes to the end of this video. What I'd like you to do is go back over it, make sure you understand it, make sure you take notes on it, because you'll need it for our task next week. Any questions, remember we have our Q&A session Wednesday afternoons.